Sweet. Okay. We should see the slides with the links now. What's up? Happy Thursday. Welcome to the Voltage Workshop. I'm just going to check to make sure we're live and stuff like that. Okay, we got the chat here. Looks like it's working. So sweet. We'll start a little bit slow here. I'll leave the links up for a minute and just talk while people check in and join. But yeah, the links will be available here on the side. And basically this slideshow, how I like to do this, is the slideshow will have all the links to everything, all of the code. So there's completed projects here if you just want to skip to the end and get it working, or if you know what you're doing. But through these slides, we're going to go step by step and kind of put together the project. And I'm actually going to build it from scratch along with you, even though there's already the completed version. So hopefully these slides should just be that one central place that you need to kind of get a link to, and then everything else should be able to be found in here. So hopefully that's pretty easy. What is up? I see people coming in Discord and on YouTube and X. So very cool. We'll get started in just a minute here. Yeah, man, it feels like a Friday, but we're building Thursday. It's 4 p.m. my time. I have a fresh, hot cup of coffee, so I'm stoked. Sweet. So I've done some, I guess, like workshops and tutorials before, kind of separately on Keysends. So it's a pretty deep topic. It can be a little bit complex. It was definitely very complex for me at first, but it's nice revisiting this because I think I've been able to simplify a lot of the concepts and then also just kind of simplify the code to give us just the most bare bones implementation of sending, receiving Keysends with L&D. So we can kind of just learn the concept and then maybe do something a little more advanced later on beyond that. But yeah, I guess let's get started. So as I said before, here's the links to these slides, tinyurl.com/voltage-keysend. These should work. Let me check this link. I should be able to go to that and it'll link me right here. Cool. Great. And then we have a GitHub version of the completed project, and there's also a Replit version. So, you know, we're going to be making a React app. So some people might not have their local environment set up with Node and everything in order to kind of spin up a React app. So this is where Replit is a good solution. You can make a free account and then just create a new, basically a new code base inside of the browser and work inside of it from there. So it's a great environment for that. So I just kind of have it duplicated on GitHub and on Replit for you. And then Voltage also has an article about Keysends from quite a while ago, but it is still all accurate and worth reading. So that's a good high-level article. But basically everything it talks about there, we're going to go over in the first part of this workshop. So cool. This is the Voltage Keysend workshop. Welcome. And I'm Austin. I do developer relations here at Voltage, and it's pretty cool. Okay, so this is the overview of what we're going to be learning about and then doing through this workshop. So first, we're going to do a little bit of theory and get our minds around what Keysends are, why you might use them, the use cases, how people are using them. And I'll give a little sneak peek. I do think that Keysends are quite underutilized. It's a very powerful feature that's, in a way, quite simple. And there's very few companies, very few products that are really leveraging it. So I'm excited to talk about that. But we're going to go over what are Lightning Keysends, how they work, what you can do with Keysends, and then we're going to talk about what we will be building. And you will have an opportunity to set up a free MutinyNet Lightning node with Voltage. I think this is probably the best way to follow along with a workshop like this, or I mean, it's my favorite way to do Lightning development now, is with these nodes. Like, I used to use Polar, I used to use all sorts of different means, but the MutinyNet Lightning node on Voltage is so easy to work with, and you can create a free account with just an email, and you get at least one of these MutinyNet nodes. So I highly suggest you really go to voltage.cloud right now and get that spun up, but I'll have a slide on that a little bit later. And then we're going to set up our project. There will be a little bit of configuration here for our React app, and after that, we're going to get right into building each piece of the key sending flow. And will we test on mainnet? I don't know. Maybe if I'm feeling spicy by the end, if I'm feeling confident, we might connect to one of my mainnet nodes and fire a few payments off. Cool. So let us get started from the top. What are Lightning keysends? So a keysend is simply a Lightning Network payment that is pushed to the recipient via their pub key. And so this is an improvement on the traditional flow where a recipient must create an invoice up front, right? So we can simply push payments to an end party, which I think in a lot of ways, people that are maybe new to Lightning, they almost assume that this is how it works, because this is a little bit of how Bitcoin works. You know, if there's an address, we can just push new payments into that address on chain without really any permission. But it's a little bit different in Lightning without keysend, and we'll touch on that a bit more in a second. So how do keysends work? So basically, in a keysend, the sender creates a random pre-image and sends it along with the payment to the recipient. The recipient uses the pre-image to hash it, confirming that the payment is valid without needing an invoice. Okay, so once the payment is received, the recipient reveals the pre-image, proving the payment was successfully complete. So maybe you're not totally tracking that, and definitely drop any questions if you have them, but I'm going to go over this a bit more. But basically the pre-image and the hash, these are these two pieces that are really important for Lightning Invoice. And this is basically a little bit like the lock and the key. And so normally these are split up between the sender and the recipient, but in keysend, we package the lock and the key together and we just send it out to the recipient. Okay, and so we'll see that flow, yes, right here. So the traditional Bolt 11 payment flow, we have, it's kind of like a handshake process, right? I want to pay you 100 sats. You generate a Bolt 11 invoice with the amount, a payment hash, and a pre-image. Okay, so you have all three pieces there. You send me the invoice only containing the payment hash, right? And I will pay that invoice using the payment hash to create a payment route. So that's kind of one piece that the payment hash is used for. And then you can verify the payment by revealing the pre-image that matches the hash. Okay, so the pre-image is just this random string that gets hashed. And the pre-image is a little bit like the key, and the hash is a little bit like the lock, I suppose so in this scenario. And then the keysend payment flow, we have a guy just pushing right here. It's a little bit different. I want to pay you 100 sats. I generate a pre-image up front, and I compute its hash. I send the 100 sats along with the pre-image to your public key without needing an invoice. So you have both pieces of information. And then you receive the payment. You use the pre-image to verify and finalize the payment by checking it against the hash. So basically, I'm just sending this care package of sats over to you, and all your node has to do is unpack it and be like, oh, there's a pre-image and a hash here. I can just claim this payment instantly. So that's a little bit of this difference. We take out this handshake flow of needing to make a deal together, and I can kind of just push the full deal to you, allowing you to claim those sats. Okay, so I hope that makes sense as like a high-level overview. And we'll get a little bit more in the details right here as we pull up a bunch of JSON. So in concept, this is a little bit simple. It's like, okay, we just usurp the normal invoice flow, and we need to generate this pre-image up front. We need to pack it in the payment. How do we do that? That is where we look at L&D here. So these are screenshots from the L&D send payment v2 command. I think it's called send payment sync on there. I'll pull it up in just a second. But this shows us, this is an example request. And we see the request body here. It has a bunch of different fields. Not all of these fields are required. In fact, most of them are optional. But there's an important field here that we need to get a little bit familiar with in order to work with Keysends. And that is the dest custom records, which stands for the destination custom records. And so we see here the description from the API. It says dest custom records, an optional field that can be used to pass an arbitrary set of TLV records to appear which understands the new records. This can be used to pass application-specific data during the payment attempt. Record types are required to be in the custom range of that number greater than equal to 665,000 when using REST, and the values must be encoded as base 64. Okay, so why is this important? This is important because this is where we will actually need to embed our pre-image. And I kind of have an example here. It looks really weird because these custom records, they're essentially a way to broadcast what kind of features your node supports. So maybe your node doesn't support Keysends, in which case my payment would fail, right? So on the dest custom records, I want to check that your node has this record, 548.237.3484. This is what's confusing, is the fact that these are random numbers, but these are actually associated to a specific feature. So this record is special. It carries the pre-image to the destination. And then the number below, 343-49334, is the optional keysend message. And we'll get into that in a second. But yeah, you can actually send messages with these keysends as well, which is pretty dang cool. So I'm going to pull up the L&D API. And so I have send payment sync right here. So this is that method I was just looking at with the request body and everything. And then we see a description here of all of the fields. So this is I love the L&D API. This is a really nice explainer. So you can really dig into each request and see what you can do. And then the dest custom records, this is what we saw. And yeah, essentially that's the consideration for I guess for sending a keysend, is we need to ask ourselves, like, what kind of request body are we sending to L&D? What do we need to have in it? And so I guess this is just a little bit of a basic example of what that should look like. And don't worry, we're gonna get into this more. I just wanted to introduce you to the custom records and the idea that they are associated with these very specific ID numbers. Okay, cool. So let's talk about what you can do with Keysends. So there's really a lot here, and there's many ideas that I can't even think of, or that other people might not have thought of, that you can apply Keysends to. So we have spontaneous payments, obviously send funds without requiring an invoice. There's encrypted messaging, so we can send encrypted messages along with the payments. That's pretty cool, directly to our peer. Service triggers, we can have automated actions like API calls or service activations. You know, there's definitely some application to keysend payments and like API services and stuff like that. Streaming money, you can continuously send small payments over time. Obviously, micropayments, you can stream micropayments. We've got better donation tipping. And then it makes a nice like proof of payment package that you can send to someone that kind of lets a little different relationship of the proof of payment to happen between the two parties. So those are a few things you can do with Keysends. There's actually some companies that are using Keysend in their product right now. These are the only ones I could think of off the top of my head. So I would love if you all know of any others that use Keysends in some kind of way. I would love to hear about it, but these were what came to mind for me. So Sphinx is obviously, they're one of the first companies to kind of come out and talk about this feature and leverage it. And Sphinx basically uses it for messaging where every message must be a payment. It kind of helps with DDoS. It kind of helps, with just making sure that as you're sending messages that, you're not going to spam away all of your money. So it's a powerful use case there. I think they use it in pretty more sophisticated ways. The Sphinx product goes quite deep, but at least for the messaging app kind of use case, they're definitely covering that. The Bitcoin company has a very simple Keysend feature, but a very important one, which is auto withdrawals. They have a few different ways that you can get auto withdrawals from like your reward balance or something like that in Bitcoin company. And one of the ways is Keysend. And this is a really cool experience because if you connect your node via Keysend with Bitcoin company, it's like as you're earning rewards, you're getting these notifications as these payments are literally pushed to your node in real time. So it's a super powerful experience in my opinion. We've got Podcasting 2.0 and Fountain, which kind of go together here, and they use the push payments for, I believe, the boostograms and the what do you call it? Value for value streaming. So a little bit of our use case that we talked about earlier. But yeah, so those are some pretty dope use cases. But like I said, I mean, I wonder what else is out there that people are doing today. And I wonder what kind of ideas you all could think of for ways that you could apply Keysend. Cool, so what will we be building? What we're gonna build is gonna look just like this. It's gonna be a simple React app for sending Keysends and then detecting, decrypting, and rendering your received Keysends, so the Keysends that you've received. And so where I've complicated this in the past is having an app where I'm trying to have two different nodes talk to each other, but we're actually gonna use one node for this. We're just gonna have our node pay to ourself because we can allow self-payments through the L&D API. So that will be a great way just to kind of test with one node. But of course, all this functionality works, when you're paying or receiving from another node, all the same. Okay, so now is a good time for you, if you haven't already, to check out the free MutinyNet Lightning node with Voltage. So you can go to app.voltage.cloud, create a free account with an email and password. You can go to Lightning Node's new node, and then you can select MutinyNet right here and spin up a new MutinyNet node. And so I have my Voltage dashboard here. I actually have two different MutinyNet nodes here, but we can see kind of what this looks like. I could go to MutinyNet. We see it's totally free. And I could continue here and just give it a name and a node password like usual. Oops. Sweet. But I already have one pulled up, so I'll open up let's open up this MutinyNet node. And I'll just keep my dashboard unlocked here. There we go. So you'll want a node up and running. You need to have a connection to a node for this workshop to work. You could also, if you're local, you can use Polar over localhost. But with Replit, that becomes a little more difficult because you actually need a global host for your Lightning node. But okay, so my node is up here. And we now know how to get a free MutinyNet Lightning node. And if you don't know what MutinyNet is, it's just a signet that is very popular amongst developers. It's a little bit new. It was made by the Mutiny team, which is why it's called MutinyNet. But yeah, it's just basically a test network that's really easy to work with. In MutinyNet, they have, you can get MutinyNet coins, open channel here. They also have a faucet, faucet.mutinynet.com. And so you can get channels, NWC, you can connect to them. They have federation, they have all sorts of stuff here. And then if you go to mutinynet.com, they have a block explorer and a mempool space instance. So these are just these three tools alone are just so powerful as a Lightning developer. It just allows you to really move fast and not bump up against your environment all of the time. Okay, cool. So getting funds in a channel, so I just pointed out the faucet.mutinynet.com and then mutinynet.com. And then you can also just click the orange buttons there. So super easy to get some on-chain and then a channel opened in just a minute. Okay, let's get started building our Keysend app now. For about 20 minutes in, so that's a pretty good time. So as I mentioned before, you have the option to do this through Replit or do it locally. So, you know, choose whichever one you want. And then the link to the completed Replit is on that tiny URL link in the top right. I'm going to be doing this locally, and I'm going to spin this up from scratch along with you. So let's get into it. And I'm going to start copying these commands just like you will, and we'll step through this. So I'm going to copy this command. This will be to create our new Vite app. Open up my terminal here. I'll do, nope, not that. Okay, create Vite app. We're going to call it Keysend Workshop, and then we're going to use the React template. Now we'll take just a second to spin up. Cool. And now I will cd into Keysend Workshop. I'll do code dot, and this should open up my little code base here. Great. Can close this out now. So now we have a simple Vite React app. It's very basic, and we're going to do some installs now. Are we? Oh yeah, we're going to configure Tailwind and install our other packages. So I'm going to copy this giant command. We're just going to get all the boring stuff out of the way first, all the configuration. So I'll install all of that. And then after that, we will run npx tailwind css init -p. Give this a second. It might give me a few dependency errors, but that's okay. I don't need this to be secure because I'm just on MutinyNet. Yep, there we go. Nice. And we'll add Tailwind config. Okay, great. And now let's copy these two pieces. So first of all, we have update Tailwind config right here. So I'll just copy all of this. I'll go into my Tailwind config, and we'll paste it over. And then the Vite config, I'll grab all of this. I'll go into vite.config.js, and we'll paste it over. And so this is just adding Tailwind. Is it necessary? I could have just done, you know, just an HTML, default HTML styles, but I don't know. I just couldn't stand to look at it. Okay, app.css is next. We're going to add our basic kind of default styles for everything. So I'll go into app.css, and I'll just overwrite it all with what is on that slide. Great. And then we're going to update app.jsx to make sure that Tailwind is working. We'll just check ourselves before we continue and kind of run all this for the first time. So I'll go to app.jsx here inside of source. I'll paste all of this over. And then we can run our project now, and we should see hello world with a red background. We'll do npm run dev. And let me actually zoom in here for you. There we go. Should see that. Okay, npm run dev. And let's see what we get here. Cool. Seems to be working. So we've configured Tailwind in our styles. Beautiful. And okay, so that is all done. So we have our basic project configured. We can count that as being out of the way. So next we are going to grab our node credentials, and we're going to add them to our environment variables. So this is the piece where we are going to need to basically configure our app to be able to read in these secret variables. And this is going to be host, which is going to be our Lightning node host, and then our admin macaroon. So we're going to grab our API endpoint first, and then our admin macaroon, and we're going to name them like so inside of our .env. So let's do that. I'll grab my API endpoint here. And in the root of the project, we'll make a new .env. And this will be vite underscore LND underscore host. Host. There we go. And then we'll also have vite underscore macaroon equals. And I can go grab my macaroon here in manage access, macaroon bakery. And I'll just copy the hex of my admin macaroon. So this will be the full admin permissions token to my Lightning node. Normally, I want to be super, super careful with this. But this is just a MutinyNet node, so the coins are not real. So that kind of makes it nice. We can be a little more reckless. Okay, there's my hex macaroon. Cool. So we have our only two required environment variables in place. That wasn't too bad. Okay, next we're going to update our app.jsx. And we have 2 slides of this. This is going to build our basic kind of boilerplate for our app. So I will copy this. And we'll go in app.jsx. Get rid of these dots. I shouldn't have put that in there. And then we'll just paste directly from this next slide. And I'll just paste that right there. And we can do format document. Great. So, bunch of code here. We are setting aside some state for our keysends, state for form data, pub key, where we have a handle input change. This is going to be for our forms. And then, yeah, basically our UI, which we'll kind of see all of that rendered in just a second. So with that in place, I imagine, oh yes, we need to create a new getInfo function. So the first thing we're going to try and get to work with our app here is just getting our basic info from our node and showing our pub key at the top. So since we have app.jsx in place, let's copy this. And I'm going to create a new folder. We're going to call it lib, new file lnd.js. So this is just going to house all of our, functions that access LND. Seems like a good way to organize the project. And I paste this in, and very simply, we are pulling in our macaroon and host. We're creating a new instance of LND, which is kind of just like this is a request object that's pointing to our LND node at the 8080 port, which is the REST port. And then we're including our macaroon here, as the basically authentication to be able to talk to our node. And with getInfo, we simply just get the getInfo endpoint and we return the data. So that's not too bad. And then next we will add getInfo into app.jsx so we can fetch the node pub key. So I'm just going to click on this. I'm going to copy from handle input change up. Back into app.jsx. And paste. Great. And now we have getInfo, and we have this use effect, which will run every single time the page renders, and it will just fetch the info. So let's save that. Let's go back to our app and see if it works. Let's refresh. Let's see, maybe we forgot a step here. Refresh. Seems like our Tailwind is not working. Let's see if console. At undefined getInfo, undefined, we must have messed up something with our environment variables. Let's check. We've got vite LND host, that looks correct. Vite macaroon, that looks correct. Vite macaroon, vite LND host. Let's just try and reload this. Maybe it just didn't load in our environment variables. There we go. Okay, that all looks correct. Sweet. So our environment variables are loaded in, and let me zoom in. And we can see we're connected to our pub key at the top here. And we can console log inside of app.jsx, where we fetch our get info here. Let's just console log fetched info. And we'll call it node info. Sweet. So here's the info from my my node, alias Austin test 2, block hash, chains, and we see Bitcoin network signet. We see all of our features here. Remember when I was talking about features before? You see that keysend is enabled. That's actually an important thing to note. I think it's on by default, but sometimes in your node settings, you actually need to manually enable keysends to allow yourself to receive keysends. So if something doesn't work, it's possible that is the case. But okay, great. So that piece is working. Next, we want to create a function for sending keysends. And we're going to want to think about this a little bit deeply for a second. So let's think about what we need to do. So as we talked about the payment flow earlier, I guess we have a basic idea of what we should do. But we basically need to create a new preimage up front. We need to create the hash for that preimage, right? The lock and the key to our Lightning payment. We need to build a valid request body for sending the keysend, right? So that's the request that will go out to send payment sync that we were looking at earlier. And then, yeah, we send it to that endpoint. And I have a link here, once again, to that, this request right here. So really, that's the big challenge. The big challenge of this is like pre-generating the preimage and the hash. And this can be confusing a little bit sometimes because there's a lot of different cryptography libraries and which ones do you do, and sometimes encoding and decoding between different formats is weird. So that's something that I sort of took care of here. Okay, so let's copy. Oh wait, I need to go out of full screen. Let's copy this, and this will be the start of our send keysend function. And let's paste it in the lnd.js file here. And we're just going to look at what's here right now. Cool. So send keysend. We're passing in a destination, an amount, and a message, right? So the destination, that is just going to be the pub key that we're sending it to. Of course, the pub key of someone else's node or our own. The amount that we're sending, and then a message that we're going to pass in as well. And so first of all, we're making the preimage here, and you can see it's just a random 32-byte string, right? That's all it is. So it's not some special piece of information that's associated with our node. It's just a random preimage. We're generating it. We are turning it into a hex string right here. Okay, so we have this hex preimage, and then next comes the hash. So we use SHA-256 to hash the preimage. You know, that's it. We just hash it with SHA-256. It's not double hashed or anything like that. And then we have that payment hash, and we just convert that to a hex string. And then we have these two buffers here. So if you don't know what buffer is, it's just a format for binary data, essentially, I think. Am I wrong about that? And we're just setting this aside because we're going to need this here for another conversion, because we're going to go from hash to base 64. I know it's confusing, but the LND API tells us that, you know, it must be encoded as base 64. So that's something that we should know. Where does it say that? Right. Yeah, right here. Values must be encoded as base 64. So we knew that up front. And it's just a question of how you get to that base 64, which maybe I took the long way, but you know, this is what I ended up with as a start. So that's the start of our send keysend function, just generating the preimage, the hash. We're getting a hex version, and then we're getting a buffer version. Okay, and this will be the entire rest of the send keysend payment function. I'm going to copy this. We're going to paste it in, and let's walk through it. Great. So we're starting this all the same, destination, amount, and message. We got our pre-image, our hash, and then we have the buffer versions of each of them. And then we go right into building our request body. And so first of all, we have our destination. So this is going to be the public key. So we do buffer from destination hex to string base 64. So we're just turning that hex pub key into a base 64 pub key. The amount of our invoice is obviously just the amount. Payment hash, we have a payment hash buffer dot to string base 64. Okay, so base 64 of the payment hash. And remember, the payment hash is kind of like the lock, right? And the pre-image is the key because the pre-image generated the payment hash. All the payment hash is just the SHA-256 of the pre-image, right? So that's the only relationship here. It's not super complicated. We have a final CLTV delta. This isn't totally necessary. This just shows basically the number of blocks required before they can claim it, or until they can claim it. We've got allow self-payment true. This is very important because we're going to be testing this on ourselves, just paying ourselves. And then the dest custom records. Here we are finally, back where we started. So this is our special two numbers. This 548 number being what associates to the pre-image that we are sending over to them. And then the 343 number is our message, which we're also converting to base 64. And it was in the format UTF-8, so that's just like the normal text format. So it's worth noting here that the message in Keysends is optional. You don't have to send a message. Just like with a payment, you don't have to send a memo or an invoice. But we're going to send a message because it's fun, and like that's, I don't know, I guess the functional kind of thing that we're doing with this workshop is we want to send some messages to ourselves with payments. We got fee limit fixed to 1,000 here, millisats, and then the dest features 9 for the feature bit of TLV onion payloads. And is that actually necessary for this? I forget. I built this like 2 days ago. What is it? TLV? No. Dest features. Feature bit. Assumed to be supported by the final node. Okay, so these are the features we assume that the final node should support. For TLV onion payloads. Okay, yeah, so the onion payloads, that is what actually allows us to embed this data inside of the onion message that gets sent across the Lightning Network. So hopefully it's not too confusing. But okay, there it is. That's the request body. That's the whole damn thing. You know, it can take a lot of work just to get up to this point. But it's a good request body. We like it. It's our summer body. But yeah, and we'll console log that before we submit, right? So we're just generating some values here. We create our request body, and then we simply call a post request to channel/transactions with the request body. And console log the data, and we return the data or an error. Okay, cool. So that is one of the hardest functions here. I can make a little more room here. But we understand it now. It's a few steps that are kind of happening, basically like 3 steps: generating our values, our request body, and then sending it. Okay. Great. Let's get to a point where we can test that out. So we put in our send keysend. Now let's import it into app.jsx and add a handler. So I'm going to copy all of this up and handle send keysend, handle input change. Yeah, so that's what we're going to be changing here. So back into app.jsx, I've got handle send keysend, and I'll go all the way up from here and paste in. Great, and now we see we're adding, importing our send keysend function into here. And the only real difference is now is we have this function that can call send keysend. And handle send keysend is being used right here on this form on submit. So this is our simple form for submitting a keysend. So pretty straightforward flow here. Let's save that. And let's test sending a keysend to ourselves. Okay, so let's reload here. Let's just see if everything breaks. Nope, doesn't break, and we're still connected here. Oh, I want to get my console log. We added it, but we accidentally removed it, so I'm just going to add console.log, get info, and fetched info. Okay, sweet. So we see get info here. So I'm going to open up this object, and I'm going to grab my identity pub key. And this will be our destination. Let's send ourselves 69 sats. And we'll say, what's up? Let's clear this. Okay, let's see if it works. Our first keysend payment. What will happen? Okay, we see our request body. Nothing looks empty. And it tells us keysend sent successfully. Okay, great. I see this object here has the payment hash and the pre-image, and it shows our route with the hops. That's kind of funny. We hopped 3 times just to end up back to our own node. But there we go. That looks like a valid payment to me. We, even though we are both the sending node and the receiving node in this scenario, you can kind of see how as a node, we just like all of a sudden we get this payment, we get this message, and we're like, oh, what is this? Oh, here's a payment hash. Oh, look, here's a pre-image, right? I can actually claim this payment right now. So that's kind of what our node is seeing. But okay, cool. So it looks like we sent a keysend. It sure looks like it, but we don't see our received keysends yet. So that's going to be the final step here, is to read in the keysends that we sent to ourselves or that other people sent to us. So let's get into that. Okay, so next we want to create a function for detecting and rendering keysends. So what do we need to do? We need to fetch invoices, which is an endpoint here for it on LND, list invoices. So we're going to fetch invoices and filter by is keysend. LND actually has a property here that we can look right at to tell if it's a keysend. That's pretty nice. We want to extract and decode the keysend message from each invoice. And then we're going to return each keysend invoice formatted with a date, an amount, and a message. So according to our app.js X component, it's just expecting these 3 properties, right? Give me an amount, give me a date, and give me a message, and I'm going to render it in my list. So that's what we're going to try and return with our function here. But let's take a peek at list invoices. Which will be right here. 1 second. Okay, cool. So here's the list invoices endpoint. It's pretty simple. We see an example request body here. A very simple request body. They're actually not even sending a request body. They're just sending the basic options. And they get this list of, oh wait, no, this is the request and this is the response. The response will be a list of invoices. And so we can have these different properties for these requests. Reversed, creation date start, creation date end, pending only, index offset. Yeah, so we'll be using a few of these. But yeah, this is the endpoint, that you will want to get familiar with. And just remember, like I put here before, the goal here is like, now we're on the other side of this transaction. We essentially want to look into our own invoices, and we want to pull out these properties that were sent to us inside of desk custom records. Okay, so now we'll grab this fetch keysends function. I got the full thing right here, and we will walk through it. We'll put this into lnd.js, and I'll put this at the bottom here. And I'm just going to format all of that. Great. So fetch keysends. Sweet. So first thing we do is make the request to v1 invoices, and we pass in these params. So pending only false. So we're basically saying only give us settled invoices, right? That's all that the keysends are going to be. And then number of max invoices 1,000. I'm just saying that for right now, for limit. I don't even think my MutinyNet node has 1,000, but you know, it's just a good property to have to not accidentally crash your app if you read in too much data. So we make that request, and we expect that response.data.invoices will have a length. So if we have invoices, we continue on. So we say keysend messages is equal to response.data.invoices. Cool. So next we're going to filter that. So keysend messages is this dot filter. So we're looking at each invoice and we're saying it must have is keysend true, and the invoice.state must be settled. So we're just being extra explicit here. It must be settled. It must be a keysend. We're reversing it here actually just to get it to appear in the order of most recent invoices, which we'll see that in a second. And then we map it out. Okay, so we've already filtered it for our keysends. We reversed it in the right order. And now we're going to do an operation on each invoice. So for each invoice, we're saying custom records, invoice.htLCs of 0.custom records. So this is what's a little bit gross in this part of the flow, is like digging through the data object of the invoice and grabbing all of the properties you need or detecting if they're there. Yeah, it can be a little bit weird, but that's what I have here. We grab the full custom records. I say the message record should be equal to this number. And that's actually all that we have to pull out for displaying keysends, really. We don't need to pull out the pre-image. We could, but our node is already verifying that pre-image and just accepting the payment immediately. So that's pretty nice. We don't need to manually do that. So we simply just pull out the message record, and then we decode the message by taking it from base64 to a UTF-8 string. So pretty simple, just decoding there, grabbing the message. And then we return it. We return an amount with the invoice.value. We return a date, a new locale string that takes the settle date, which is a Unix timestamp, and just turns it into a locale string. And then we return the decoded message. So that's for each invoice. We do that. We return it. And then we just do one last filter to make sure that the message is not empty. And after that, we return it. So, you know, a few steps in there, but let's look at that again. All we're really doing is making the response, making sure we have invoices. We're filtering them by if they're keysends, reversing them, and then we're pulling out the message and returning the amount, date, and message for each one. Cool. So I think that makes sense. So let's see it in action. Let's see if we can get this thing to work. So we're going to import fetch keysends in app.jsx and fetch them on render. So let's copy this code from handle input change up. I'll do that. And into app.jsx. Here we go. Sweet. And so now all that changed here, I'll save that, is that in our fetch data function, right? So when this runs on render through the use effect, we're fetching the info and setting the pub key, but we're also fetching the keysends with fetch keysends and setting them to keysends. In which case they get mapped out in our UI right here, received keysends, keysends.map. Great. Oh, and look at this. This is actually something we had commented out before as well. Inside of handle keysend, whenever we send a keysend, let's make it to where we immediately refetch. That way we can see our new keysend that we sent to ourselves, which I guess this is only really relevant if we are sending to ourselves, which we're doing. But hey, that's cool. Let's do it because it'll make for a nice demo. Okay, and that should be, I believe, the last piece. And we should see our invoices listed out. Okay, let's jump over. Boom, here we go. There we go, our received keysends. And we see the one I sent to myself at 4:39:38, about 10 minutes ago. What's up? And then these are all the keysends I've sent to myself in the past few days testing this workshop. So there we go. Let's test this live one more time. Let's get we need a console log and fetch data. I lost myself. Okay. Console.log fetched info. Cool. Identity pub key. Okay, let's give it a whirl. Do 22. Hello world. Okay, taking a second. Keysend successfully, and boom, it shows up just like that. That's beautiful. That's a nice experience. Okay. We could clear out the forms here. That could be a basic improvement on our front end. But with that is the very last slide, 31 slides here. And we finished in about 15 minutes. That's not too bad. So definitely, drop any questions here in the Discord if you have them. And do I want to hook this up to one of my mainnet nodes? I think it's worth a try. I've got like 10 minutes. Let's do it. Let's send a mainnet keysend to ourselves. Maybe something fun will happen. Maybe it'll break. I'll go to, actually, I want to go to this node, I believe. No, not that one. That's my main one. Mainnet, cool. And what is it? No. Cool. Okay, so this is one of my mainnet Lightning nodes. Have a pretty small balance on here, 13K sats. But let's just go replace these environment variables. That should be all that's necessary. So I have my host here. It's okay if I dox this to you all, but I'm gonna want to be careful with my macaroon for sure. Even though there's not many funds on this, I still want to be careful. So we'll copy the hex here and paste it in, and we'll just jump away, and we can restart our app. Cool. Let's try it on mainnet. I wonder if I have any keysends to this node already. I'm not sure. Maybe I got some from Bob, from Bitcoiner Bob. That wouldn't be surprising. Okay, back to our app. Refresh. Whoa. Okay, have I got some keysends? Look at all of these satograms. Nice. Okay, so we are connected to a mainnet node. I see some ads here. You can tell they're ads because they're all one sat. But that's very cool. I guess this is showing another use case. Oh my gosh, how foolish of me for forgetting in my slide before. Satograms is one of the coolest implementations of keysends that's out in the wild right now. It allows you to send ads like this to people directly to their nodes and pay them for the ad. Very cool. But okay, let's try and send to ourself on mainnet. So this is our new destination now. This is my pub key. I'll send 100 sats. Testing keysend live LMAO. Okay, let's see. Send successfully. It's not fetching it. Yeah, something went wrong here. Let's try and refresh. Yeah, interesting. I'm not seeing it. Let's try that again. To my own pub key. Let's do 21. Hello. And let's make sure we're console logging. Let's see. Our response from send keysend. Response.data. This is probably our success handling. We're probably not handling failure cases very well right now. Oops, I forgot to send in 21. Hello. Okay. Keysend sent successfully. No route. Oh, of course. Okay. Sweet. So that is something that we can definitely improve in here. So you notice when we do handle send keysend, we literally just send the alert, right? We don't actually check any statuses or anything like that. So that would be a good thing to add. In fact, we could say, you know, const response equals await. And then we can say if response.payment preimage or payment route. That's one thing we can also check here. So let's say if response, I'm going to say payment underscore route. Then we have a success. If there's a payment route, it means a success. Else, we want to send an alert, error sending keysend with response. Yeah, that looks good. And that way, when we fail here, object, response.data. Let's try it again. Oh, response.payment error. That's what we want. Payment error. We'll just do a check to make sure that exists and we don't crash our app. Okay, let's fail a payment one more time. Error sending keysend, no route. Okay, well that's a useful message now. So I don't have a route. I don't really want to open channels on mainnet right now. And I don't want to risk touching my real Lightning nodes macaroon, but nonetheless, we tried on mainnet. We know it works on MutinyNet. So yeah, I think that was a success. And we now have an error case here that we added. So I'll probably push this to the final version, just for, you know, a 1% improvement. That seems good. But yes, sweet. So thank you for joining. We had 31 slides here, quite a bit of theory, quite a bit of practice, but we got our Keysend app up and working. And once again, you can find the completed projects for this on GitHub and on Replit at this tiny URL link in the top right. And yeah, just let me know of any future workshops you want, any future topics around Lightning or Bitcoin that are developer related that you want to learn about, and I would love to dig into it and put something simple together. So yeah, I hope this was useful. I hope it was kind of fun. And keep an eye out next month. I'll be doing another workshop, probably around a similar topic. And of course, check out the Voltage Discord. We're going to have events that go on throughout the month, mainly focused on developers, people working with Lightning, with Bitcoin. So definitely come talk to us, come hang out with me. And I'd love to hear about what you're working on. So sweet. Thank you all. And I think we'll call it there. So cheers, happy Thursday. I'll see you next time.